Hello and welcome back to our channel, 10 Minutes Exploration, where we explore the wonders of the universe and beyond. Today's topic is, how big is our universe? The universe is everything that exists in space and time, from the smallest subatomic particles to the largest galaxies and beyond. But how big is it exactly? And how do we measure it? Well, that's not an easy question to answer, because the universe is not only very big, but also very mysterious. In this video, we will try to explain some of the methods and challenges of estimating the size of the universe, and some of the possible answers that scientists have come up with. Let's begin. One way to approach this question is to look at the observable universe, which is the part of the universe that we can see with our current instruments. The observable universe is defined by the distance that light has traveled since the beginning of the universe, about 13.8 billion years ago. This means that the observable universe has a radius of about 46.5 billion light-years, and a diameter of about 93 billion light-years. But wait, how can the observable universe be bigger than the age of the universe multiplied by the speed of light? Shouldn't it be only 27.6 billion light-years across? Well, that's because the universe is expanding, and has been expanding faster than the speed of light since the Big Bang. This means that the space between galaxies is stretching, and the galaxies are moving away from each other. So, when we look at distant galaxies, we see them as they were in the past, when they were closer to us. And the farther away they are, the more time it takes for their light to reach us, and the more they have moved away since then. The observable universe contains about 2 trillion galaxies, each with billions of stars and planets. It also contains many other fascinating phenomena, such as black holes, quasars, supernovas, and dark matter. The observable universe is a vast and amazing place to explore, but it may not be the whole story. The curvature of the universe describes how space is bent by the presence of mass and energy. It can be measured by observing how light rays travel in space. If the universe is flat, light rays will travel in straight lines. If the universe is curved, light rays will bend either towards or away from each other, depending on the sign of the curvature. There are 3 possible types of curvature for the universe: 0, positive, or negative. A 0 curvature means that the universe is flat, like a sheet of paper. A positive curvature means that the universe is closed and spherical, like a ball. A negative curvature means that the universe is open and hyperbolic, like a saddle. The curvature of the universe is related to its density and expansion rate. If the density of the universe is equal to a critical value, then the universe is flat and has 0 curvature. If the density of the universe is greater than the critical value, then the universe is closed and has positive curvature. If the density of the universe is less than the critical value, then the universe is open and has negative curvature. The critical density of the universe depends on its expansion rate, which is measured by a parameter called the Hubble constant. The Hubble constant tells us how fast the universe is expanding at any given time. The higher the Hubble constant, the lower the critical density, and vice versa. The topology of the universe describes how space is connected as a whole. It can be thought of as the shape of a rubber sheet that can be stretched or twisted without tearing or cutting. The topology of the universe determines whether it is finite or infinite, and whether it has any edges or boundaries. There are many possible topologies for the universe, depending on its curvature and geometry. For example, a flat universe can have a simple topology, like a plane, or a complex topology, like a torus or a Klein bottle. A closed universe can have a simple topology, like a sphere, or a complex topology, like a projective plane or a Poincare dodecahedral space. An open universe can have an infinite topology, like a hyperbolic plane, or a finite topology, like a hyperbolic horn. The topology of the universe cannot be determined from its curvature alone, because there are different topologies that have the same local curvature. For example, a sphere and a torus have both positive curvature locally, but they have different global properties. To distinguish between different topologies, we need to use other methods, such as observing patterns in cosmic microwave background radiation or gravitational waves. So, does this mean that the observable universe is the same as the whole universe? Not necessarily. The observable universe is limited by our ability to detect light and other electromagnetic radiation. There may be parts of the universe that are too far away for their light to ever reach us, or that are hidden behind other objects, or that emit radiation that we cannot detect. In fact, some scientists believe that the true size of the universe is much larger than the observable universe, and may even be infinite. One way to estimate the true size of the universe is to use a mathematical technique called Bayesian model averaging, which combines different models of the universe based on their probability and consistency with observations. Using this technique, some scientists have estimated that the universe is at least 250 times larger than the observable universe, or at least 7 trillion light-years in diameter. But even this estimate may not be accurate, because we don't know for sure what kind of shape or geometry the universe has. Is it flat, curved, or something else? Does it have an edge or a boundary, or does it loop back on itself? Does it have more than 3 dimensions of space? These are some of the questions that cosmologists are still trying to answer, using theoretical models and observational data. As you can see, the question of how big is our universe is not a simple one to answer. The universe is so big that it defies our imagination and challenges our understanding of physics and reality. But that's also what makes it so fascinating and exciting to explore. Thank you for watching this video. If you enjoyed it, please like, share, and subscribe to our channel for more content like this. And don't forget to leave a comment below with your thoughts and questions about the size of the universe. Until next time, stay curious and keep exploring.